Okay, this is the P1 paper from June 2023. It's question number 5, and as we can see by looking through this question, it's a radians question. We're going to be working out arc lengths, we're going to be working out areas of sectors, etc. Always a really good idea to read these questions. They can be quite imaginative with what they ask. In this question, they're saying this is the plan of a garden. Okay, sometimes it's a logo, sometimes it's other things. I always check then to see how much of this information is already written on the diagram. So it says OA and CD are perpendicular to OD, right? Fine, first of all, they're both at 90 degrees, or pi over 2, because we're working in radians. AB is the arc of a circle. Yeah, I can see that with center O, radius 4, but that means that that's a radius 4 in there as well. BC is parallel to OD. I can see that, I don't need to put anything on from that. And then they're giving me the lengths. OD is 6, OA is 1.5, sorry, O is 4 and the other one's 1.5. Can we find the angle AOB? So angle AOB is this angle here. Let's call it theta. That's what I'm trying to find, is that angle there. And actually everything to me is pointing towards finding this other angle here and then doing pi over 2 minus it. Why would I look at that other angle? Because if I draw this line in down here, don't never be afraid to put extra lines on a diagram. If that's 1.5, then look, I've got this right angle triangle in here now. Okay, and if I've got that right angle triangle, I can use tan, sine, and cos to work it out. So I'm actually going to work out alpha. I'm going to work out that answer there, and I'm going to do pi over 2 minus that to give me theta. Right, I've explained all that to you. Let's explain it to the examiner. Up to you whether you want to draw the diagram out. I'm going to, but I don't know that I necessarily would if I was doing this in the exam because of speed, but I've got a little bit of time, and just to make it clear to everybody watching the video then, and I'm actually going to call this X here then, just to make it super clear. So we've got this situation where that's pi over 2 here, and we've got 4 and 1.5. But if I'm trying to work out alpha there, hopefully you don't need any support with that. That's just tan sine, it's sine, isn't it? Sine alpha is opposite over hypotenuse. So sine alpha will be, in this case, 1.5 over 4. So inverse sine of that, alpha is going to work out to be equal to 0.384. Now remember, that's not what I wanted. I'm trying to, it's nice as they told me the answer, I'm trying to get 1.186 for theta for AOB, but AOB, we'll call it theta, but it's just pi over 2 minus that one. So pi over 2 minus that, and thankfully, yeah, that does work out to be 1.186. And I did 384 to 3 decimal places because I knew what I was going to be getting my final answer to. Okay, that's part A done. Part B says find the perimeter of the garden, giving your answer in meters to 3 sig fig. Okay, never forget to come back and look at these decimal places and significant figures. Perimeter then, so the perimeter, let's just change the colour for a second, is going to be that one, plus that one, plus that one, plus that one, plus that one. Now we've got 6, we've got 1.5, we do not have this one here, and we certainly don't have the arc length. I'm going to do the arc length first, so I'm going to do, let's get rid of all that stuff, I'm going to do AB I'm going to do this one, and then I'm going to do that one. Okay, so AB is the easiest one to do first of all, because it's just the arc length. Change my pen back. So for part B, arc length AB, L is equal to r theta. So that's nice and easy. We've just worked out what theta is. So L is equal to 4 times, what was it, 1.186. So that gives me 4.744 meters. I'm going to do everything into 3 decimal places. Keep an eye on our accuracy when we're going through and doing it. So the next one I've got to do is to work out BC. But actually, if I want to work out BC, I'm going to use this line here. And what I'm going to do, use the same triangle I had here, use this triangle in here, okay? If I know this length, and I'm looking for that length there, OX there, it's just Pythagoras, isn't it? It's just 4 squared, take away 1.5 squared, square rooted. So that will give me OX, and if that gives me OX, then XD is just 6 take away that. And obviously BC and XD are the same thing here. Okay, let's make that clear to the examiner then, more importantly to the examiner. So I'm going to say OX is equal to, I'm not going to draw the diagram out again this time, just simply because the amount of time I want to do for this video. 4 squared take away 1.5 squared, like I just explained. So that works out to be 3.708. And then remember the length I'm looking for, I'm going to call it BC now. The actual length here is 6 minus that. So that works out to be 2.292. I'll put it back on the diagram, but don't necessarily need it on the diagram there. That's 2.292 now. And we had that this was 4.744 here. But now I've got enough information to work out the perimeter. I want to make it clear to the examiner, so I might actually just take the extra couple of seconds to say, when I'm working out the perimeter here, it's going to be, go back and look at the diagram, but it's AB, BC, CD, DO, and then OA. So then in case there's any method marks going, I'm certainly making it clear what I've actually done, in case I made a mistake somewhere. Don't think I have in this particular instance, but you always could do, couldn't you? Plus, and then we've got 1.5, we've got 6, and we've got 4 there. So that all works out to be equal to 18.536. I kept it to 3 decimal places, but what do they want? They just want 3 sig figs. Okay, so there's no problem with that. I've got this answer here, but to 3 significant figures then is 18.5 meters, and make it clear that's actually my answer. And previously with that one, that was my answer. Okay, so that's A and B done. Let's have a look at part C now. So part C says, can we find the area of the garden? And we want it in square meters, 3 sig figs again. Okay, so the area of the garden, I'm going to do it as being, now you might want to break it up differently to me, but I'm going to work out the area of the sector. And then I'm not going to do the triangle and the rectangle separately. I'm going to do this as a trapezium. I've got all the information to be able to do that. So I'd rather do that trapezium than break it down into 3 shapes. But you can do, if it makes it easier for you to break it down into 3 shapes, then you do that. I'm just not going to in this instance. Going to tell the examiner what I'm doing though. So if I'm going to do the area of a sector first, area of sector is half r squared theta. We should all be aware that it's half r squared theta. And I've got all the information. Okay, it's a half 4 squared times, now just make sure you're getting the right numbers each time as to which angles you're using. That's that, which works out to be 9.488. Then area of a trapezium I'm doing this time. So the area of a trapezium would be half A plus B times H. And if we're doing that, A, B, and H. Okay, so shouldn't need to explain to you IGCSE stuff, but that's where those values are going to come from. So that's going to be a half of 6 and 2.292. See the value sometimes of having all the information that you just stuck it back on the diagram here, 1.5, so that you're not copying any incorrect lengths of the calculations you've already done. Anyway, this works out to be 6.219, and then so area of the garden, the whole thing is equal to 9.488 plus 6.219, and then whatever that all works out to be. And it said 3 sig figs, so I'm not even going to bother doing it. I'll do it and make it accurate at the same time there, 15.7. So yeah, useful question to go through just to make sure you're clear with all your methods. Don't make any silly mistakes on this question. This should be a good mark earner for us. So hopefully that will make sense to you.